In this module, you will learn how to find the square of a number. Given a square of side 2 units, how will you find its area? You need to find the square of the length of its sides. It is quite easy to find the squares of small numbers. But finding the squares of large numbers is not easy. For example, to find the square of 37, you have to multiply 37 by 37. If you find that a bit difficult, there is an easier way. We can simplify things if we write 37 as the sum of two numbers whose squares we can easily find, like 30 and 7. So, 37 square is equal to 30 plus 7 whole square. This can be written as 30 plus 7 into 30 plus 7. Now, let's simplify. Thus, we find that the square of 37 is equal to 1369. Now, consider these numbers and their squares. On observing carefully, a pattern is seen. The last digit of all these numbers is 5, and the last two digits of their squares is 25. Now, let's analyze this pattern further. 15 square is equal to 225. 225 can also be written as 200 plus 25. This can be written as 2 into 100 plus 25, which can be further written as 1 into 2 into 100 plus 25. Similarly, we can write 25 square and 35 square. Based on this pattern, can you predict the square of 45? The last two digits of the square of a number ending in 5 are always 25. Consider the digit before 5 and then multiply this number with its next whole number. Here, this number is 4. So, we are multiplying it with the next whole number, that is 5. Thus, the square of 45 is equal to 2025. Based on these examples, we can generalize that if a number is of the form a5, then a5 square is equal to a into a plus 1 into 100 plus 25. Now, let us talk about some more interesting square numbers. Remember the Pythagorean theorem? This theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is, AB square is equal to BC square plus AC square. Now, what are the numbers that would satisfy this condition? One such set of numbers is 3, 4 and 5. Since 5 square is equal to the sum of 3 square and 4 square, 6, 8 and 10 is another such combination. A set of three numbers that satisfies the Pythagoras theorem is called Pythagorean triplet. More Pythagorean triplets can be found using a formula shown here. 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square. Remember, here m is any natural number greater than 1. Putting m equal to 2 in the expression, we get Pythagorean triplet 3, 4 and 5. Putting m equal to 3 in the expression, we get the Pythagorean triplets of 6, 8 and 10. You can try putting in different values of m to find Pythagorean triplets. In this module, you learned that the square of a number is obtained by multiplying the number with itself. If a number is of the form a5, then a5 square is equal to a times a plus 1 times 100 plus 25. A set of three numbers that satisfy the Pythagoras theorem is called a Pythagorean triplet. Formula for finding Pythagorean triplets is 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square, where m is any natural number greater than 1.